Okay, we're starting a new chapter, 7.1, Operations on Functions. We're going to be looking mostly this chapter on square root radical type of equations and their inequalities, but we'll start with some just generic operations on functions. So we're going to talk about two functions, f of x and g of x, and we're going to talk about what we can do with them. We can add them, subtract them, multiply them, or divide them. So the first two you're looking at here, we're going to be adding them and then multiplying, multiplying, subtracting, and then dividing. So if we're going to take two functions, divide them, then we just have to add the two functions together. We're going to multiply them, we just multiply the two separate functions together, etc. In the last case, you say where g of x is not equal to 0, because remember we can't divide by 0, so the function can't be equal to 0 in order to do dividing of two functions. So for example, example 1, we have two functions, f of x, 3x squared plus 7x, and 2x squared minus 1. We're going to try adding those functions together, so all we have to do is take the first function, 3x squared plus 7x, and add it to the second function, 2x squared minus 1. We're going to combine like terms and get our final result function, which is 5x squared plus 7x minus 1. We'll do the same thing, subtracting functions, 3x squared plus 7x, subtract 2x squared minus 1. Make sure we distribute that minus sign to both terms, and we'll end up with x squared plus 7x plus 1, because it's minus a negative 1. Okay, example number 2, x squared minus 9 and x plus 3. We're going to multiply those two functions. So we have two binomials. We're going to FOIL them out and see what we get. So we're going to get x cubed plus 3x minus 9x minus 27, and we can't simplify that any further. Finally, f divided by g, x squared minus 9 divided by x plus 3. Well, we can divide that if we think about the numerator, x squared minus 9, being a difference in squares which can be factored. So often if you want to divide functions, to really successfully do it, you're going to have to factor the numerator and see if you can divide out the denominator. So x plus 3 times x minus 3 over x plus 3. Our x plus 3's will cancel, leaving us with x minus 3 as our final function, or result. Now a new idea of dealing with functions is called composition of functions, and this can get kind of confusing. So we're going to, in a composition of functions, the outputs of one function becomes the inputs of a second function. So there's two ways of saying it and using this terminology. So the first term where we have f with that funny little open circle, g, and then of x. Okay, so we're going to be doing a composition, what we say was f of g of x. That's how you read this function right here, f of g of x. Same thing here, we say f of g of x. So you think about g of x inside the parentheses. G of x is what you're going to worry about first, and then you're going to evaluate that function as a function of f. Now, the other way you could say it is at g of f of x. And g of f of x is there's two different ways of writing what is saying the same thing. And the way you say it in language is g of f of x. When you're doing composition, order matters. So f of g of x is not the same as g of f of x. There's one case where it is, but we'll talk about that. That's a special case. Most of the time, you'll get different results, so they're not commutative. You have to do them in the right order. All right. So in the case of f of g of x, you're going to evaluate g of x first, and then plug what you get from g of x into f of x and look for that result. Okay. So let's try. Now, we're going to consider the functions as a series of ordered pairs to start with, and then we'll get into variables pretty soon. So your function f of x, you have these ordered pairs 2, 6, 9, 4, 7, 7, and 0, negative 1. The idea is the x value is the 2, the y value is the 6, or x is 2, f of x is 6. For the next value, 9 is x, and 4 is f of x, etc. Okay, so same thing with g of x. You have 7, 0, negative 1, 7. So 7 is the x value, and 0 is the g of x value. So if it says to do a composition of f of g of 8, then what you want to do is first evaluate what g of 8 is. In other words, plug in 8 for the x value of g, and see what you get out. And if you look at the g of x, when you go g of 8, the x value is 8 from the g function, then the y value is going to be 2. So the output of your g of x function when you're evaluating at 8 is 2. So you say f of 2. And f of 2, so you take that y value from the x and you plug it into the f function and you see what you get. So if you plug in 2 for x in the f function, you're going to get 6. So f of 2 is equal to 6. All right, a little confusing. Let's try the next one. G of f of 9. Okay, first we're going to take 9 and plug it in to the f function in the x value. So 9 into the f function, right up here. The x value is 9, and see what you get out for y. In this case, you're going to get 4. So you'd say that f of 9 is equal to 4. Now take that value and say what g of that value. So in other words, what is g of f of 9 or g of 4? If you look at the g function and you look for an x value of 4, you find it right here. So g of f of f of 9, which is g of 4, is equal to 9. All right, now let's try f of g of x. Okay, so f of g of x, we're going to plug in the x value for g. This is more of a generic function. Actually, before that, we're going to jump to these problems over here on the right. And f of g of -1. Okay, so let's go ahead and try it. I'm going to pause, or I would like you to pause, and go ahead and try to evaluate f of g of -1, g of f of 7, and then we'll come to these generic functions of g of f of x. But try to evaluate -1 and 7 on your own. So pause the video and try to work those out. Okay, if you're back, hopefully you found that g of -1 is 7, and therefore f of 7 is 7. If you plugged in the next function, g of f of 7, then you took 7 and plugged it into f. Remember, you go right to left on this, kind of weird, but you evaluate f of 7 first, and you plug that result into g. So f of 7 is 7, and you plug that value into g, and for the x value for 7 for g, you should get 0. Okay, so f of 7 is 7, g of 7 is 0. All right, now we're going to do the generic functions. So in this case, what we're going to do, we're going to go ahead and sort of find all of the solutions for these two functions for evaluating f of g of x. So, for example, look at the g of x function. In the first ordered pair, we have 7, 0. So if the x value is 7, that would be the g of x value. Then the g of x value is to 0. So g of 7 is equal to 0, and then you can take that 0 value and go up to the f of x function, and here you find it up here. When you have 0 for x, you're going to get -1 for y. So if you start with 7, you're going to get -1 for y. Let's go to the next value. We have -1 comma 7. So -1 comma 7, I'll plug in -1, I'm going to get 7 out. Okay, so let's take the 7. Now let's go look at the f function and see if you plug in 7 for x, what do you get for y? In this case, you get 7. Okay, so we'll look at the next ordered pair. We got 4 comma 9. X is the value for 4, so we're going to take 4. That kicks out 9 as the g of x function. Then we take 9 and look up to our x and see if we have a value, and there it is. When we plug in 9 for x, we're going to kick out 4 for y. So we start with 4, we end up with 4. And then the last value, 8 comma 2, 8, we plug in 8 in for x, we get out y. We take that 2 value for y, and we look to our x function. We have that 2 comma 6. So when we plug 2 comma 6, you're going to get the 6 value out. Now I understand that's confusing. Pause, go back, take a look at it again, try to understand how exactly you're going to work this f of g of x. Now we're going to do the reverse. We're going to go g of f of x. Okay, so, hold on, I'm going to pause this for 1 second. Okay, g of f of x, we'll look at the f of x function first, and we're going to start with the 2, 6. When 2 is the x value, then we kicks out a 6 as the y value. And then we take that value of 6 and we look into our g function, and I don't see an x value for 6 anywhere in the g function, so we would just say it's not going to be possible. All right, so let's try the next one. 9, 4. We plug in a 9 value for x, we're going to get out a 4. Let's look to see if there is a g of x, and there is. We got a 4, 9 down here, so we'd get 9, 9. Let's try 7, 7. So we got 7 goes in, we get a 7 out. Let's look to see if we have a function with a 7 in the g of x. There it is. And so we plug in a 7 from there, we're going to get out a 0. And finally, 0, -1. We plug in a 0, we're going to get out -1. Do we have an x value for the g of x function at -1? Yes, we do. So we plug in a -1 here, we're going to get out a 7. And so our final solution set is just the 3 ordered pairs where we do get an x and a y value. That first one didn't have one, so we just drop it. Okay, so that one is undefined. So our solution set will be 9, 9, 7, 0, and 0, 7. All right, so here are another set of examples. In this case, you have variables. So we don't have the ordered pairs, we have variables. So let's try the first one, and then I'd like you guys to try the other ones on your own. So f of g of 1. So what we're going to do is we're going to take this 1, and we're going to plug it into our g function and see what we get. And then we'll take that result and plug it into our f function. Okay, so let's see what we get. G of 1 is going to be -1 minus 5, or -6. Now we take that value, -6, and plug it into our f function. We're going to get 2. F of -6 is 2 times -6 minus 1, which is -13. Okay, so go ahead and pause the video. Try to figure out the remaining ones, and I'll take you through all of them once you come back. Okay, g of f of 1, I take f of 1, plug 1 into the function f, 2x minus 1, and I'm going to get 2 minus 1, which is 1. Take that value, g of 1, plug it into minus x minus 5, I'm going to get -1 minus 5, which is -6. Moving on, g of -4 is -4 minus 5, which is -9. I'm sorry, -1. Wait, hold on a second. Yep, that's right. G of -4 is -1 because negative and -4 becomes +4. 4 minus 5 is -1. Okay, so now we got -1. Now f of -1, because we're doing f of g of -4, f of -1 is 2 times -1 minus 1, which is -3. G of f of -4, f of -4 is 2 times -4 minus 1, which is -9. Take that value and plug it into g function. -9 minus 5 is going to be, let's see, +9 minus 5, which is 4. And then f of g of x, okay, now we're going to take the function g of x and plug it into f. Right, so let's take a look at how that works. We have -x minus 5, that's the g function. We're going to take 2 times that minus 1. So this is where we're going to take the composition of an entire function. I take my minus x minus 5, which I got from my g of x function up here, and I plug it into my f function over here where I see an x. So I get 2 times minus x minus 5 minus 1. So the composition of those two functions, f of g of x, is minus 2x minus 1. Now, go ahead and pause and try to do g of f of x. So you can do it in reverse order. Take the f of x function and plug it into g and see what you get. Okay, when I do that, I get minus 2x minus 1 minus 5. Now I simplify. Minus 2x plus 1 minus 5, which is minus 2x plus a -4. Okay, notice that the two functions we just found are different. We talked about how in composition order matters, so it's not commutative. F of g of x is very different than g of f of x. Okay, so now we have a little bit more complicated functions. I'd like to go ahead and try these on your own, and I will reveal solutions in a moment. So go ahead, pause the video, and try to do these functions, f of g of 4 and then f of g of x, etc. Okay, and I will reveal solutions momentarily. Okay, let's take a look at this f of g of negative 4. That would say take negative 4 and plug it into the function g. If you plug it in the function g, you're taking the square root of a negative number. Now what do? Well, you can't take, sometimes you can have square root of a negative number, you're going to get an imaginary number, but in this case, when we're dealing with composition of functions, we don't allow that. We're only going to deal with functions where we have all real numbers as our solutions. So that one essentially cannot be evaluated. Okay, we'll go on to the next one. G of 4, that just means evaluate the function twice in the same function. So the square root of 64 is 8. Then you take that result and plug it back into the function again. Square root of 8 is 2 radical 2. And then finally f of g of x. Take the g of x function, stick it into the f of x, and see what you get. So the square root of x squared plus 2 times the square root of x. And that can be simplified to x plus 2 radical x. That's it. That's as good as you can get it. For all x is greater than 0, because we're going to do a positive number since we're not going to do any square roots of negatives. And then g of f of x says take the square root of x squared plus 2x, and that cannot be simplified any further. Also true for values where x is greater than or equal to 0. And that concludes our lesson.